Hi there. Thanks for joining us today. I have your resume here, and it looks like you've been working with Angular for about 2 years now. We are looking for someone who is solid with the fundamentals, but is also starting to think about more complex architectural patterns. How are you doing today?
Yeah, I'm doing great, thank you. Yeah, I'm really excited to be here and talk about my experience. I've spent the last 2 years diving deep into the Angular ecosystem, and I feel like I've reached a point where I'm very comfortable with the core framework and starting to tackle more advanced challenges.
That is good to hear. Let's start with some of the basics just to get a feel for your mental model. To start, can you tell me what the primary purpose of an Angular component is? How do you view them in the context of a larger app?
Sure. At its most basic level, an Angular component is the fundamental building block of the user interface. I think of a component as a way to encapsulate a specific patch of the screen. It combines a TypeScript class, which handles the business logic, data state, and behavior, with an HTML template that defines exactly how that data is presented to the user. By breaking a complex page down into these small, independent, and reusable pieces, the code becomes much easier to maintain. Instead of having one massive file for a whole page, I can have a header component, a sidebar component, and several small card components, which makes the project much more organized.
Right, the modular approach. Now within those components, you're often dealing with data binding. Could you explain interpolation and how it differs from property binding and event binding?
Definitely. Interpolation is probably the most common one we use. It's when you use double curly braces in the template to display dynamic data from the TypeScript class. Essentially, it converts a variable or a small piece of logic into a string and drops it right into the text of the page. It is great for showing labels or names. Property binding is different because it doesn't target the inner text of an element. Instead, it targets a specific property of an HTML element or a component using square brackets. For example, if I want to disable a button based on a boolean in my TypeScript, I would use property binding on the disabled attribute. Then you have event binding, which is essentially the opposite direction. While interpolation and property binding move data from the logic to the view, event binding is one-way communication from the view back to the logic. We use parentheses for this, like when a user clicks a button and it triggers a function in the class. So in short, interpolation is for showing text, property binding is for controlling element settings, and event binding is for handling user actions.
That's a very clear distinction. Just to double-check a specific detail there, if you had to summarize the core difference specifically between property and event binding, how would you put it?
I would say it comes down to the direction of the data flow. Property binding is a one-way flow from the TypeScript code to the HTML template. It allows the developer to set the value of an element property dynamically. Event binding is the reverse flow, where data or a trigger moves from the HTML template back to the TypeScript code, allowing the app to respond to the user.
Makes sense. Let's talk about the DOM. In Angular, we have different types of directives. Can you explain the difference between a structural directive and an attribute directive?
Yes, structural directives are the ones that actually change the layout of the DOM. They can add, remove, or replace elements entirely. You can always spot them because they usually start with an asterisk, like ngIf or ngFor. A structural directive decides if an element should exist in the DOM at all. Attribute directives, on the other hand, only change the appearance or the behavior of an element that is already there. They don't add or remove anything from the DOM tree, they just modify it. For instance, adding a custom class or changing the color of an element based on a condition using an attribute directive. So, while a structural directive manages the existence of the element, an attribute directive manages its properties.
Speaking of ngIf, can you elaborate on what it actually does under the hood? Some people confuse it with just hiding an element with CSS.
That is a common misconception. Using CSS to hide an element, like setting display none, just keeps the element in the DOM but makes it invisible. The ngIf directive is much more powerful. It conditionally adds or removes the HTML element from the document object model entirely based on whether an expression is true or false. When the condition is false, the element and all its children are completely destroyed. This is important for performance and memory management because those destroyed components are no longer taking up resources or running their own internal logic.
Good. Now let's move into the life cycle of a component. How do you detect when a component has been initialized?
For that, you use the ngOnInit lifecycle hook. This is a special method that Angular calls automatically after the component has been created and, more importantly, after all the input properties have been set. Always make it a point to put my initialization logic there, such as fetching data from a server or setting up initial variables. Avoid putting this kind of logic in the constructor because the constructor should really only be used for simple dependency injection. By the time ngOnInit runs, the component is fully ready to interact with its inputs and the environment.
That's a solid practice. Now let's talk about data fetching. Most Angular apps need to talk to a backend. What is the purpose of the HTTP client module?
The HTTP client module is the built-in module that provides the service needed to make HTTP requests to a backend server. Its main purpose is to enable the application to communicate with external APIs to fetch, send, update, or delete data. It essentially wraps the browser's native fetch API but gives us a much more powerful toolset. For one, it uses observables to handle asynchronous data streams, which allows us to use operators from RxJS for things like mapping or filtering data. It also has built-in support for interceptors, which lets us modify requests globally, like adding an auth token to every header. Plus, it makes it very easy to convert JSON responses directly into TypeScript objects.
You mentioned observables. That leads me to a question about the templates. What is the significance of the async pipe when you are working with those observables?
The async pipe is incredibly important for preventing memory leaks. In Angular, if you manually subscribe to an observable in your TypeScript code, you are responsible for unsubscribing when the component is destroyed. If you forget to do that, the subscription stays alive and you get a memory leak. The async pipe handles all of that automatically. It subscribes to the observable when the component loads, updates the view whenever a new value arrives, and then automatically cleans up and unsubscribes when the component is removed from the DOM. It makes the code much cleaner because you don't have to write manual subscription and unsubscription logic in your class.
Speaking of transforming data in the template, what is the general concept of pipes, and can you give me an example of a built-in one?
Pipes are essentially filters used to transform data directly in the HTML template before it gets displayed to the user. The key thing is that pipes don't change the actual value of the variable in the TypeScript class, they only change how that value is presented. This keeps the business logic separate from the presentation logic. A great example of a built-in pipe is the DatePipe. If I have a raw ISO date string in my TypeScript, I don't want to write a complex formatting function in my class just to show it as month, day, year. I can just use the DatePipe in the template and let Angular handle the formatting.
Let's shift gears toward dependency injection. How do you actually inject a service into a component?
To do that, we use the dependency injection pattern. First, I create a service class and mark it with the injectable decorator. This tells Angular that this class can be injected into other components or services. Then, in the component where I need the service, I declare the service as a parameter in the constructor, usually marking it as private. Angular's DI system then looks at the type of that parameter, finds the correct instance of the service, and provides it to the component during instantiation.
Now imagine a more complex scenario. What happens if you have two different services that share the same class name, but you need to inject different implementations of them? How would you resolve that conflict?
That is a tricky situation because Angular typically uses the class name as the unique identifier for injection. If you have two classes with the same name, it causes a conflict. To solve this, I would use injection tokens. By creating a custom injection token, I define a unique lookup key that is completely separate from the class name. Then, in the provider's array of the module or component, I map that specific token to the implementation I want. When I need to use the service in the component, I use the @inject decorator in the constructor. This tells Angular exactly which token to look for, ensuring the correct implementation is delivered regardless of what the class is named.
That's a professional way to handle it. Let's dig a bit deeper into the DI system. Under what circumstances would you feel the need to implement a custom injector?
I would use a custom injector when I need to control the lifetime and visibility of services outside of the standard component tree or the global root injector. A common use case is when you want to create a sandbox. If I have a specific group of components that need to share a set of service instances that are isolated from the rest of the application, a custom injector is the way to go. This is especially useful in plugin architectures or when building dynamic components using View Container Ref. Since dynamically created components don't always inherit the injector of their parent in the same way static components do, a custom injector allows me to manually inject specific configuration or state into those dynamic components.
I like that you mentioned dynamic components. Let's talk about the evolution of the framework. What is the significance of the standalone flag in components?
The standalone flag is a huge quality of life improvement in recent Angular versions. In the past, every single component had to be declared in an ng module, which created a lot of boilerplate code and made the project structure feel heavy. By setting standalone to true, the component becomes self-contained. It manages its own dependencies by directly importing the specific components, directives, or modules it needs in its own imports array. This simplifies the architecture, makes components much easier to reuse across different parts of the app, and it actually helps with tree shaking. Because the dependencies are more explicit, the build process can better remove unused code, which reduces the final bundle size and helps the app load faster.
Very true. Now let's talk about forms. Angular gives us two main ways to handle user input. What are the two modules and what is the conceptual difference between them?
The two modules are the Forms module for template-driven forms and the Reactive Forms module for reactive forms. The core difference is where the logic lives. Template-driven forms are more like the old Angular JS style. Most of the logic, like validation and tracking changes, is handled directly in the HTML template using directives like ngModel. They are great for very simple forms, but they can be harder to test because the logic is tied to the view. Reactive forms move all that logic into the TypeScript class. You explicitly create form control objects and group them into form groups. This gives you way more control, makes it much easier to implement complex custom validation, and makes unit testing far simpler because the form structure exists independently of the HTML template.
In your experience, why are reactive forms generally preferred for professional projects?
I prefer them because of the scalability and predictability. In a professional environment, forms rarely stay simple. You often need to add or remove fields dynamically, or you need to react to a value change in one field to update another field in real time. Reactive forms allow you to do this easily because you can subscribe to value changes using observables. Also, because the form state is managed in the class, you can write unit tests for your validation logic without even needing to render the DOM, which makes the development cycle much faster and more reliable.
Let's move on to routing. What method should you use to initiate a navigation change between routes programmatically?
To trigger a navigation change, you should use the router service. Specifically, I would call the navigate method. This method takes an array of commands as the first argument, and you can pass an optional object for navigation extras as the second. There is also the navigate by URL method, which is useful for absolute paths, but in most of my work, I use the navigate method because it's more flexible for passing parameters and navigating relative to the current route.
Let's talk about state management. When you're designing a complex application, what is the best practice for sharing state across unrelated modules?
The best practice is to decouple the state from the UI components. Avoid passing data through long chains of components or using a global store for every tiny variable. Instead, I create dedicated feature-based services that act as a single source of truth. These services use reactive primitives, specifically behavior subjects, to hold the current state and then expose that state as observables. This way, any unrelated module can simply subscribe to the slice of state it needs without needing to know about the other modules. Now, for very large-scale applications, I would suggest a formal state management library like ngRx or Akita. These libraries enforce a strict unidirectional data flow using actions and reducers. This makes the state highly predictable and makes debugging much easier because you can use developer tools to see exactly how the state changed over time.
You mentioned ngRx and the use of reducers. This brings up the concept of immutability. Can you explain what immutability is in the context of state management and why it's so critical?
Immutability means that once an object or an array is created, it cannot be changed. In a system like ngRx, instead of updating a property inside an existing state object, you create a brand new copy of the state with the updated values. This is critical because Angular's change detection and ngRx rely on reference checks. If you mutate a state object directly, the reference to that object remains the same. Angular might not realize that the data inside the object has changed, which leads to those frustrating bugs where the UI doesn't update even though the data did. By replacing the old state with a new object reference, the framework instantly sees the change and triggers a UI refresh. An added benefit is time travel debugging, where you can jump back to previous versions of the state because every single change was saved as a distinct, immutable snapshot.
That's a very important point. While we are talking about change detection, let's get into the weeds a bit. How does Angular's change detection system determine what to re-render? And specifically, how does the on-push strategy change that behavior?
By default, Angular uses a tree-based change detection system. Whenever an event happens, it checks every component from the root down to the bottom to see if anything changed. In a large app, this can become a performance bottleneck. When you mark a component with onPush, you're telling Angular to skip that component and its entire child subtree during a normal check. It will only re-render if one of three things happens. First, if one of its input property references changes. Second, if an event originates from within the component or its children, like a button click. Third, if the developer manually triggers a check using change detector ref. The most important thing to remember with onPush is that it relies on reference checks, not deep value checks. If I have an object as an input and I just change a property inside that object, the reference stays the same. Angular will see the same reference, assume nothing changed, and the view won't update. This is why immutability, which we just discussed, is so essential when using onPush.
I'm glad you connected those two concepts. It shows you understand how they interact. Now a bit of a throwback question. What is the difference between ngApp and router module for root?
Those are actually from two different eras of the framework. ngApp is an old directive from Angular JS version 1. It was used to tell the browser exactly where the Angular application started. Router module for root, however, is used in modern Angular version 2 and above. It's a method used to configure the routing system for the entire application. It tells the framework which routes to use and whether to create a separate service for routing to manage navigation. So one was about bootstrapping the app, and the other is about configuring the navigation system.
Fair enough. Let's wrap up with a couple of final thoughts. Throughout your 2 years of experience, what has been the most challenging part of working with Angular for you, and how did you overcome it?
I think the steepest learning curve for me was definitely RxJS and the concept of asynchronous data streams. Coming from a traditional imperative programming background, thinking in terms of streams and observables was a bit overwhelming at first. I remember struggling with things like switching between switch map and merge map and accidentally creating memory leaks because I wasn't unsubscribing. Overcame it by building a few small side projects specifically focused on RxJS and reading through the official documentation. I also started using the async pipe more consistently, which simplified a lot of my code. Once I understood that everything in Angular is essentially a stream of events, the whole framework started to make a lot more sense, and I actually grew to love the power that RxJS gives you for handling complex data flows.
That's a very common struggle, and it sounds like you handled it the right way. I appreciate the detail in your answers and your ability to link different concepts together. Do you have any questions for me about the role or the team?
I do. I'm curious about the current state of your codebase. Are you guys moving towards standalone components and the newer Signals API, or are you still primarily using ng modules? I'm really interested in how the team is adopting the newer features of the framework.
That's a great question. We are actually in the middle of a gradual migration to standalone components. We aren't doing a total rewrite, but any new feature is being built as standalone. We've also started experimenting with signals for local state management to see if we can reduce our reliance on some of the heavier change detection patterns. It's a very iterative process for us.
That sounds like a great environment. I'm really interested in those kinds of migrations because it's a great way to learn the differences between the old and new patterns.
Absolutely. Well, I think that covers everything I wanted to ask today. It was a pleasure talking with you. We will be in touch soon regarding the next steps.
Thank you very much for your time. I look forward to hearing from you. Have a great day.